Hello, everybody. Thank you all for joining us. I appreciate those of you who are watching us on YouTube and LinkedIn. As like kind of a housekeeping note, some of you may have in the past joined us on Crowdcast, and unfortunately, the Crowdcast. If you've been here before, you know that Crowdcast has been failing me. So we are now just doing live on YouTube and LinkedIn. So I appreciate you joining us. I'm going to do a little bit quick intro before I turn it over to Feross to talk about the dark side of open source, like very ominous sounding, but I'm sure it's not as ominous as it seems. So a little bit. First of all, I want to thank our sponsors. So for those of you who've been here before, you know, like all this stuff costs money to run, and they make it so I don't have to shell out of pocket to keep these running all these free events for you. We run a ton of free events. So like, you know, they allow us to do that. So composable.com, if you ever heard of like composable architectures, basically, it's a way of building your full stack application and keeping and bringing in multiple data backends from different APIs and third-party sources, etc. So like this is really popular, for instance, with e-commerce applications. Composable.com will give you all the resources. If you don't know composable architectures and don't understand like composable e-commerce and all that stuff, they can teach you everything you need to know, plus a bunch of libraries and other stuff that's all free. So check it out at composable.com. And Netlify has been a sponsor since day one. I really appreciate Netlify for that. CFE.dev is hosted on Netlify. I've been a customer since, I think that I did a thing, they had it once where you could figure out what number customer you were, and I was like 300 out of all the, you know, so it was pretty early on. But yeah, so love Netlify. Thank you for your support, Netlify. So I got one event. I'm going to be announcing a bunch of other stuff, but I've got one event that I want to tell you about. That's the only kind of one that is currently announced. Code Word Conference. So, you know, we talk a lot, like if you build applications, particularly on the web, you're probably dealing with content at some point, but we rarely ever talk about how to deal with content in code. And that's what this conference is all about. It's about like things like accessibility, you know, working with APIs for content markdown, all the kind of different CMS and all that other thing, all the other things that make up an application that has content are the things we're going to cover at this event. I've got some great speakers. The lineup's set. We're going to be announcing the schedule very, very soon. And as usual, this is 100% free. So it says September 16th. That is a mistake that I still have not corrected. It is September 26th. The date on the left is correct. The date on the right is wrong. So September 26th, 11 to 5, at like 9 speakers. It's great, completely free. You can sign up now at coworkcon.com or at cfe.dev. So that's it for upcoming events that I have announced so far, but I've got more coming. I'm always open to feedback. I love hearing from you all. So if you've got feedback, please reach out to me at brian@cfe.dev if you want to speak. Of course, if you're interested in sponsoring, I'd love to hear from you. Yes, this session is recorded. We are not on Crowdcast, but obviously at YouTube, you can go back and watch this at any point. Same as on LinkedIn. I will be posting an edited version of this video, cutting out all my yammering right here in the intro and things like that to YouTube probably in the next day or so. So you can check for that as well. Speaking of recordings, I've got I think it's like 350 recordings in the library going back 7 years. It was 7 years about last week that I ran with the first one of these. So got a lot of talks on almost any topic you might be interested in. So please check those out. Go back. It's a really great resource. And if you want to follow us, you can follow on Mastodon, Discord, YouTube, LinkedIn, Threads. Those are all the places you can find us. There's only one notable apps missing piece there. We are not on that platform. So, all right. So that's it. That was a quick little intro. I'm going to go ahead and put your screen up, and I'm going to turn it over to Feross to tell us about the dark side of open source. Oh, you're muted.
That was an auspicious start. All right. Okay. Thanks for having me here, Brian. It's great to be here. And I think folks are in for a treat. This is a fun talk. We're going to go through a bunch of cool stories of just different nefarious things that have happened in open source, and hopefully developers can leave this talk with some ideas about how to protect themselves, and also just with a little bit more of an understanding of the kind of things that go on in the wide world of all of these different package managers and different kind of places that we share open source. So to get started, let me just introduce myself. I'm Feross. I started out in open source. I spent a long time in the JavaScript community. I wrote some of the most popular packages in that world. The scale of NPM is crazy, and so very, very quickly you end up with a ton of downloads if you contribute in that community. So I got to, the great part about that was I got a chance to witness firsthand the massive growth in the way that open source is used within companies. I remember a time when there was a debate about whether open source or proprietary software was better, and I'm happy to say that open source has definitively won that debate, and everybody uses it. I then moved into security and started getting interested in that, and taught a class on web security at Stanford, and now I'm working at Socket, where I'm helping to basically build this product that's helping a ton of companies to defend their apps from different types of software supply chain attacks, which as we're going to see in this talk are only increasing. Cool. And so just a quick bit on what Socket does, so folks have the background. It's a tool that helps protect your code from everyone else's code. So it's a tool that helps developers and security teams ship faster and spend less time on security busy work. We not only fight vulnerabilities, but we also kind of provide a proactive protection from bad open source dependencies. And we've been doing really well. We have a ton of amazing customers. We're a pretty new company, only a couple years old, but already we have some amazing customers that you can see here on the screen, and we're protecting 300,000 code repositories. So we've been able to help a lot of people, and hope this only continues to grow. So with that, let's jump into the talk. So in the last 5 years, the way that we write software has undergone a massive shift. Today, it's super common to see applications where over 90% of the code comes from open source dependencies. And that means that that's code that you or your fellow developers didn't write. So the average open source dependency has 79 transitive dependencies. And in a world where you're building your application on thousands of dependencies, software security is not just about your code, it's about every piece of code that you depend on. And in this talk, we're going to just focus on open source dependencies, but really your full software supply chain includes all the third-party code you're using, the APIs, the cloud services, even the dependencies in your operating system. All of those parts and pieces make up the software that you ship to your users. And unfortunately, the open source ecosystem is under attack. I don't mean to be hyperbolic here, but we have seen a pretty dramatic increase. Some estimates put it at a 700% increase in the past year. And we are seeing these attacks impact organizations of all types and sizes. So if you use open source in any way, and obviously you almost certainly do, then you're going to be affected. It's not really a matter of if, but when. And the reason I say that is that the packages that we're seeing get compromised are these really pervasive open source dependencies that pretty much everyone uses in one way or another. And so, we need to think ahead a little bit to understand what steps can we take now so that when a popular package that we use is compromised, we won't be, in massive trouble, right? And so that's what this talk is about. Now, when we talk about software supply chain security, I know that can sometimes be super abstract. So I want to make this concrete for everyone and show you what does a software supply chain attack look like. And so this is a real example. This is something Socket detected. It's not a very interesting attack, but it's something we detected recently. And so let's take a look at it. So let me help you see what's going on in this file. I'm going to highlight a couple of parts of the file. Does that help? So if you look at these sections here, you can see that if a developer were to install this package, this malicious code would immediately run, and it would exfiltrate or steal their environment variables. So things like your secrets, your tokens, your keys that are in the environment variables, and send that to this attacker-controlled domain, which you can see is obfuscated there in the third line. So this is how a software supply chain attack directly leads to a breach. This attacker is basically, they added this code into an open source package. If anyone installs and runs this package, they're going to steal all the tokens, and then that's going to allow them to get access to further parts of your of the application. And I'll mention a couple of examples of kind of big supply chain attacks, also in case these jog your memory. But there was this big one called a SolarWinds hack. This happened a few years ago. It was a sophisticated attack that compromised a company called SolarWinds, and the attackers added in malicious code into SolarWinds software products, and they were able to then infiltrate the networks of thousands of SolarWinds customers, including U.S. government agencies and large corporations. And while the direct monetary damage is hard to quantify, the costs associated with all the investigation and the remediation and the increased cybersecurity measures ran definitely into the billions of dollars. And what's interesting about this attack is this picture here is very similar to how an attacker would compromise open source. You're just replacing the supplier here with the open source maintainer. And so the attacker can get code into the open source project, and then it will affect the downstream customers. And this is actually what we saw very recently with the XZUtils backdoor. So probably most of you have heard about this. This was massive news a couple months ago. But I'll just give a summary here and before we kind of dig in so that everyone can kind of get up to speed. So what happened with XZ was a group, likely backed by a state, infiltrated an open source data compression project called XZ by gradually winning over its main contributor, Lasse Collin, over several years. They introduced a sophisticated, though not perfectly flawless, backdoor aimed at compromising SSH servers. And the attack exploited a dependency of SSH on Linux's systemd, which relied on the compromised compression library. So this basically created a multi-layered vulnerability. And it what fascinated everybody about this attack was just sort of how long it took, the duration of the plot, and kind of the way they created multiple credible personas, and they had just an insane amount of patience. So it suggested that this was like a highly organized effort, probably from a state. And just the complexity and the way that they executed this made a lot of folks in the community think that maybe it was the same team that was responsible for the SolarWinds breach. Though I think that information on this has evolved quite a bit since the story first broke. So what I wanted to do now is just kind of show you what this attack looked like. I think it's a fascinating example of what it looks like when somebody tries to infiltrate an open source project. And we can see what we can learn from this. So let me start by first mentioning, so this isn't more of an old school open source project. It's been around for like 15 years plus, I think. You have a maintainer that's been tirelessly maintaining this project over a really long time. And they use a mailing list to discuss changes to the project. And what you're seeing here is this is this attacker named Gia Tan, this is their first email to the mailing list, and you'll notice they're adding a editor config file. So this is a very innocent change. It doesn't really do anything, but they're just trying to, I guess, build trust with the maintainer and show that they can do some useful things. This email gets totally ignored by the maintainer. A month later, there's another email from the same contributor sending another innocent patch to the mailing list. This fixes a kind of a build problem with reproducible builds. They continue to sort of send more patches along these lines, most of them getting totally ignored by the maintainer. Because again, this maintainer is pretty burned out and has been doing this for about 15 years. But then finally in February 2022, so this is now 2-3 months later, the first commit from this malicious actor has finally been merged. It's an innocent commit. It's just adding a simple null check. And the lesson from this, I think, is that the simpler the change, right, the simpler the fix, the easier it is for maintainer to merge. And so I think what the attacker learned here is that they should just fix a really, really simple bug that's a 2-line fix that the maintainer can easily evaluate and then get that merged. Then what we saw was a couple months go by and another persona shows up, Jigar Kumar. And this person sends a few emails to the list and complains about the first person, Jia Tan's patch is not landing. You can see here, he says patches spend years on this mailing list. There's no reason to think anything is coming soon. So at this point, the maintainer, Lassie Colin, has already landed 4 of Jia Tan's patches. But what's going on is sort of they're sort of trying to create pressure on the maintainer to maybe consider adding additional contributors. You can see Dennis, another fake persona, comes in here a month later and adds in mentions this phrase that is the bane of all maintainers, which is this package still maintained, which is also building on the pressure on the maintainer. And I'll just say that this is one of those things that if you send it to a maintainer, it's one of the worst things to possibly receive from your community. I've experienced this myself on some of the projects I maintain, and it's honestly super mean to send this to a maintainer asking if their project is dead, because they're probably feeling pretty overwhelmed and pretty hard on themselves already, and then to get a message saying, "Hey, is this thing dead?" isn't the nicest. And I think that this problem has gotten a lot worse in the new model of open source that we see as kind of taken off with NPM and with these newer ecosystems, which is that rather than having a single project like Linux that has dozens or hundreds of maintainers that all work on that single project, we have more of the latter model here, which is a single maintainer with tens or hundreds of projects. And in this model, it's very easy for the maintainer to get overburdened and to not really be able to handle the maintenance load of their packages. And so what we see is the maintainer apologizes for the slowness, and they add this little message here that Jia Tan has helped off list, meaning that they're communicating over some type of chat system, working on this, and that maybe he hints that Jia Tan might have a bigger role in the project in the future. And he says, it's clear that my resources are too limited. So you can start to see here that the maintainer is starting to come to the realization due to the pressure from the different posters that maybe they should consider adding other folks to the project. And then here we see another 2 messages from this Jigar character sending a pressure email over 1 month and no closer to being merged. Not a surprise. You can sort of hear the negativity in that. Same thing with this next message saying progress will not happen until there's a new maintainer. And then here you can see Lassie replying and saying that he's having some mental health issues, and that he's again hinting that Jia Tan might be able to help in the future. And then finally, we have the first commit here merged with Jia Tan as the author. There was an earlier commit with him as the author, but the name wasn't set correctly. And then finally on, sorry, I'm getting ahead of myself here. We still see more pressure being applied here. Jigar is saying, you're choking your repo. Why are you not changing maintainers? Dennis is also adding on another message. Why not pass on maintainership? So they're making it feel like there's all this community pressure to pass on maintainership. Jigar at the very end here even asking Jia why he can't commit this directly himself. And then finally, we see here another 3-month gap, and then Jia Tan finally posting the release summary for version 5.40. So this is kind of the first moment that the attacker has actually gotten commit rights to the repository. And so, what happens from here is I'm not going to get into all the technical details of it, but essentially this compromise allows, this permission allows Jia Tan to then land a set of patches that will eventually make their way into the SSH client, and then allow anyone who anyone who has the right key material to SSH into any server that's running this version of SSH. And this could have affected a significant, like double-digit percentage of all SSH servers in the world. This would have been, horrible. But fortunately, some enterprising developers discovered this suspicious code and basically traced it back to some of the stuff that Geotan was doing, and we were able to stop. The community was able to stop it before it was released, and only a few people that were running pre-release versions of their operating system were affected. But this is a crazy story because you can just see the number of personas, the length of time, the patience, right? And what I want to draw your attention to is there were months that went between some of these messages, right? If these people are working for a state, which is currently the kind of best theory we have here, that this level of persistence is almost certainly a state attacker. My question is, what were they doing for the month between those messages, right? They were obviously trying to work their way into other open source projects, right? That this was certainly not their only attempt. And so, I would suspect that there were probably, 20 or 50 other kind of similar email threads happening in different other open source projects, and it just remains to be seen, like, which of those we'll learn about. So it's quite scary, honestly, to me. And I get I really just wonder where have they actually succeeded, and so it's something we need to do better as a community. I'll mention kind of one other incident, kind of very similar to this one, and what I think is so fascinating about this event stream incident is that, so XZ was a very recent one. We learned about it this year. Event stream, on the other hand, this is something that happened back in 2017 in the JavaScript community, and it has a lot of similarities to the XZ incident. And it was really an early preview of some of these the attacks we were going to see over the coming, the coming 5 years, but it was honestly, it was a lot simpler and a lot less sophisticated of an attack. But it's kind of illustrative. So I'm gonna show you kind of what that looks like. You'll see it starts with a friendly feature suggestion from this developer Devinus, and then you can see the maintainer saying he doesn't really use this module anymore, and he's kind of not really planning to maintain it. And then eventually ends up getting an email from someone who says, "Hey, I'd love to take over this package." And Dominic just immediately gives access to the person who emails him. And I want to emphasize, this is open source working as it should. You should really be inviting in new contributors. You should be encouraging people to join the project. It creates robustness, and so nothing about this kind of really sets off that many alarm bells. I mean, it's normal for people to want to help, and so it's kind of hard to spot this. But let's continue with the story. So here you see that this is the part of the thread where folks have actually learned that there was learned that the new maintainer added a backdoor into the package. But you'll see here Dominic's reasoning for why he did it is he said he emailed me and he wanted to maintain it, so I gave it to him. I don't get anything from maintaining this module, and I don't even use it anymore, and haven't for years. And so you have a burned out maintainer not really using the code anymore. It's totally reasonable for them to, give that to somebody else to take care of. This is kind of how it happens. And then the way the community found this is the part that's also, it's super similar to XZ. It was discovered by a total accident. You have a developer who just noticed a deprecation warning getting printed out in their console, and they traced it back to the code that the attacker added. So the attacker used the deprecated function basically, and then they found out that there's this this highlighted code here was added to the bottom of one of the files, and you can see the attacker they were making a bunch of good changes, positive changes, but then eventually they added in this sneaky bit of minified code. And if you unminify it here, as the kind of this commenter did, you can pretty clearly see what's going on. So there's a payload that's encrypted on with this data variable, and the first thing it does is it just decrypts the payload, and then it evals it to basically run the code, and it uses one of these environment variables from npm as a decryption key, and so basically the key comes from kind of the project that the code is being run in, and yeah, and so we just got lucky as a community that the function that they used was deprecated right after they released the attack, and the community kind of did this massive search of all npm packages and found that it was actually this package Copay that was being targeted, and unfortunately this was an Electron application, and this bad dependency got bundled into the Electron app and shipped out to the users of the Electron app. So the malware exfiltrated the private keys from the crypto wallets of the users, and it would sneakily steal their crypto. And it was sort of I would say it was a very successful attack. Yeah. So I mean, kind of the moral of the story here is that maintainers, in the course of doing their normal work of maintaining their packages, will share access with people, and given enough time, and given burned out maintainers, and given enough persistence, it's possible for the bad guys to get into any open source project. That's just a fact. With enough time, enough patience, enough willingness to do good contributions over the course of months, years, they will eventually be able to build up trust with really anyone, and get into the packages they want to get into. And so given that developers can't read every line of code in their dependencies, we need to kind of start thinking about ways that we as a community can do better here. And unfortunately, we're not doing very good right now. It takes over 200 days to detect these malicious packages on average, and this is according to some research in Usenix security conference. And 20% of the packages that are malicious actually are caught after 400 days. So it's really bad. The other problem that's an issue here is that even when stuff is found, oftentimes it isn't added into the National Vulnerability Database, and so there's no reporting system. Obviously, for the really big attacks, they tend to get reported and discussed a lot. But for the vast majority of the attacks that are happening, they never get even documented or cataloged in a standard location, so that we as developers can scan our code and our packages to see if we're using any of those bad packages. So at Socket, we've built a system where we can actually scan code in all the ecosystems. Today, that's NPM, Go, Python, Java, and we're adding Ruby and Rust in the coming months. And whenever we find a malicious package, we report it and get it taken down to protect the community. And we're finding over 100 of these per week right now, so it's quite a lot. So we're doing our part, and then we're providing kind of the data that we collect to anyone who signs up for Socket. And we have a really generous free plan, and you can just install it for free and get protected today. So yeah, that's kind of like a summary of some of the problem. I think one other attack that's worth kind of maybe going into a bit, that it has some very, very interesting lessons, especially for anyone who's working on a web app, is the Ledger attack. This happened back in December, and there's a whole bunch of really cool lessons that came out of it, I think, for folks that are using NPM packages, that I like to dig into here, and then we'll see how much time we have to go into some of the other stuff I had prepped. So we'll see how we're doing on time. But yeah, what happened here was hackers compromised the code used in a SDK published by Ledger, and the Ledger SDK got this hacker that got access to the NPM account, and then they put code into there that would reroute funds to the attacker's wallet. And what is so interesting about it is that the users of the library in question were they were doing everything right in some sense, right? They just installed the package that they were recommended to install by Ledger. They initialized it with this await load connect kit function call. And what it turns out though is that this was actually not initializing code that was part of the npm package. What this actually was doing was it was remotely loading code off of a CDN, and then kind of injecting that into the web page with a script tag. And they did this in order to, as they say in their README here, to allow them to push out updates to the library without having every one of their users need to update their npm package. And this would allow them to kind of release builds faster. And you can see the code they used to do this is here, and I'll highlight a couple of the parts that are the most salient. You can see they're injecting a script tag into the page. Now, the problem with this is it completely bypasses the lock file and allows anyone who's able to get code onto the CDN to effectively change the code running on everyone who's using this library's website at once. So when this happened, the Ledger security team was able to deploy a fix and upgrade, update the code on the CDN, but the malicious file ended up remaining live for about 5 hours while the CDN caches while the cache was getting invalidated. And so what we learned from this is a few things. For authors of packages, they should not be hot linking to JavaScript CDNs from within NPM packages, because this is going to completely bypass the lock file and take away control from the user of the open source package. Related to that, it's really not a good practice to link to HTTP, Git, or GitHub dependencies within a package JSON. This is effectively also bypassing the lock file by allowing the code that's installed to be changed without a new version of a package being published. They also should have minimized who had access to npm publish. They had a former employee that left the company or had access, and they forgot to remove it when that person left. So we need to audit our npm access regularly, and ideally have some type of rigorous checklist-based process for offboarding employees when an employee leaves the company. And then finally, if we can, we should be using GitHub Actions workflows to trigger publishes so that no individual developer actually needs access to npm. On the user side, it's important to not use packages that remotely load code and bypass your lock file. To the extent you can identify this, you should. Socket actually does have some alerts that we'll be able to send you for packages that do those things. So if you're using Socket, you will get warned if any of your dependencies are doing this. And that your dependencies. So you should read the code in your dependencies as much time as you can afford to do that. It's really a good idea and a good investment. Or you can use a security tool that just detects these types of risks. And obviously Socket would be one of those. And then just more general advice is to the extent that you can, you should try to use fewer dependencies. You should pin your dependencies. Never use the wildcard operator. And then avoid mutable package references. So again, those are the HTTP Git URLs, as well as any type of @latest where you point to a tag, because those can be updated without your knowledge at any time by the maintainer. And so if you do these things, I think you'll be in a much better shape to avoid kind of what happened to Ledger. Yeah, and so I guess I just think when we think about kind of security tooling in how it works for developers, it's a little bit today. It's a little bit too hard to do the right thing, and so some of the things in here just require manual work, and they're just a little bit too hard for everyone to do consistently. But I think to the extent that we can, we should try our best to do these things because we're going to be much safer. But I think, like a lot of the legacy tools in the space, such as Sneak, such as Dependabot, they don't do a very good job of making it easy for developers to do the right thing. So in the case of this Ledger attack, they were reporting that the package was safe for 24 hours after the package was actually compromised. And this is because the way they report their security findings is based off of a very reactive approach of waiting for an official vulnerability or CVE to get issued. And so we just need to do better as a community. The other big problem is that we're just kind of drowning in a flood of alerts. So for anyone who's used npm audit, you know that every time you install a package, you pretty much get this warning that you're using hundreds of vulnerabilities, and it's gotten to the point where it's flooded developers to the point where they just tune these out. And there was a very famous post about this a few years ago from Dan Abramov of React fame, where he called npm audit a stain on the entire npm ecosystem. And he said the way that it works is totally broken. And I would agree with that. I think the problem with npm audit and with vulnerability scanners in general is that they're just sending way too many alerts to developers to the point where we can't even use the information that it's sending to us. We're getting false positives. We're getting warnings about vulnerabilities that aren't even, it's in code that never even is used. It's never even run. We're getting warnings for developer dependencies, which are never run in production. The severities are all inflated. Everything's a critical or a high, even though it's more likely to be a medium or a low, if we're being honest. And at the same time, these tools don't even alert about the things that we care about, like all the attacks I've been talking about this whole talk around supply chain attacks, malicious dependencies, typo squats, hijacked packages, backdoor dependencies, all this type of stuff. They don't even warn about any of that stuff. So it's really like we're in this kind of worst of both worlds situation right now. But to be positive and to try to inject a little bit of positivity in here, I would say one of the things that's helping us right now, and it's really quite promising change, is that we're actually seeing that LLMs, large language models, are able to help us get a handle on this problem. So I mentioned that the problem is developers can't read every line of code of their dependencies. There's not enough time for that. There's too much code. There's too many dependencies. But an LLM can read every line of code of your dependencies. And so at Socket, we've been using LLMs for over a year now to do this, to try to help people to get a handle on the risks in their dependencies. And this type of generative AI approach enables us to identify threats that evade traditional analysis approaches, and to take code like what you see on the left and to turn it into a verdict like you see on the right, where we're able to identify. This is actually the explanation that our system generated for the Ledger attack that I mentioned earlier, where we were able to detect the obfuscated code that was added into the package and warn our users. So, we're starting to have good tools as defenders to finally try to automate some of this and take away the toil and help developers to do the right thing without having to do a ton of work. So I'm excited and encouraged by that development. I'm optimistic about how LLMs can help us here. Cool. So I have a couple minutes here. I think I'm gonna use the last little bit of time I have to just show you a little bit of a sampling of some of the recent malware that we've found, because I think some of it's pretty cool, pretty interesting. So I just went through and grabbed a few examples of malicious packages published to different ecosystems, mostly npm, but also I think there's some Python in there as well. In the past week, just to show you some examples of kind of like what is going on out there on these package managers, and hopefully it's entertaining and interesting. So here's a package that we found that runs a curl command and basically sends your etc password file, which is the system password file, to this ngrok HTTP URL. So this is just exfiltrating this important system file. The LLM was able to identify it as malware and report that there's data exfiltration of sensitive information. So this is a very simple example, but it's good to see that it works in those cases. It's unfortunately usually not that simple. So what we more often see published to these registries is something code that looks like this. And this is code that's been intentionally obfuscated or designed to be unreadable and really as much as possible to evade any type of static analysis or code analysis tools. But fortunately, an LLM, given that it operates on language and not on the AST of the code, is able to pick up on a few keywords in this file and kind of get a sense that something nefarious might be going on here. And if you scroll down in the file, it also identifies some other things here, such as the fact that Discord is being contacted to download an exe file. We see child process, which is used to run files. We see updater.exe. There's enough in here, plus the fact that it's obfuscated, that our LLM system here, our Socket AI system, was able to identify this as arbitrary code execution, downloading from untrusted sources, and a significant security risk. So again, pretty exciting to see that we can actually use AI to help us out here as developers. Now I want to show an example that I thought was quite entertaining. So this is another example of really deep obfuscation that an attacker attempted. And in this package, you'll see that they are using on this line here a little bit of obfuscation to hide what's going on. So I want to draw your attention to, excuse me. I want to draw your attention to the type function, and the type function here is actually returning a string that is going to basically run. It's going to make an HTTP request, but they wanted to hide from a specific analysis tool that looks for the string http.request or http.get or http.post, and so they use this kind of complicated obfuscation technique in order to hide. So if I go to the type function here, we can try to figure out what this code is doing. So I'll draw your attention to here at the bottom of the function. It's passing in 0, 1, and 2 into the prop getter function. And then the prop getter function is calling the prop value function with the number in question, which is prop. But then it's also passing in prop getter, which is the function that we're running inside of. So it's passing a reference to the function here itself into prop value, which is sort of weird. And then prop value takes the function that's passed in, turns it into a string. So now we're looking at a function as a string, splits on the new lines, and then filters down to just the lines that start with // So what that means is that it's actually targeting the comment inside the function. So it's looking at these comments here, West, question, and Ireland, and it's trimming those down to basically chop out the words West, question, and Ireland, which is kind of odd. And then it's using the indexes down here to chop those strings down further to select specific substrings within those strings. So it's selecting ST, QUE, and RE. And then it reverses those and joins them together. And if you'll notice, reversing that turns into the string REQUEST in reverse. That spells the word request. So all this code just to create the string request. That's what gets returned here. And so effectively, this line turns into HTTP request. And that actually bypasses a bunch of static analysis that's looking for HTTP.request. But fortunately, our LLM is not fooled by that. So the AI systems, the Gen AI systems, are able to look at that code and to say, hey, that actually looks like it's sending environment variables, it's obfuscating the nature of the prop value function, and there's some malicious data exfiltration. So it's pretty cool stuff. I really think that AI is going to help us out a lot here, and this is kind of the path forward for starting to detect and stop these kinds of attacks. And I think this is really just the beginning of what we're going to be able to do with this technology as defenders and as developers. So, excuse me, I'm getting like some kind of a cough developing right now. I'm trying my best not to cough here. But yeah, that's pretty much it for my talk. I think basically the lesson here for us as defenders is that open source risk is really it's a complicated and multifaceted issue. there are a lot of factors that go into whether an open source package is safe and good to use. It's really a lot more than just the vulnerability stuff that we've been seeing from a lot of the tooling that we're familiar with as developers. There's so much more that you care about as a developer, like is the package, does it have good quality, right? Is it maintained? Is the author trustworthy? What kind of behavior does the code actually do at runtime? Is the license safe? And so we really want to kind of ask ourselves, these questions when we look at open source and whether we want to use those packages or not. And we should, as much as possible, zoom out and try to have a broad view of open source risk and think about as many of these factors as we can. So with that, I will say thank you, and I'll just also mention, feel free to get in touch if you ever want to reach out. And I love talking about this stuff. So if you have any questions for me and you want to talk, I'm happy to chat with anyone. You can contact me on email is probably the best, and feel free to get in touch. And otherwise, I think we'll have a few minutes for questions here. So thank you for your time, everybody.
Yeah, that was awesome. That last one was really interesting because I mean, I think, you know, it's at a certain point, most developers, if they were tasked with kind of verifying this, would have kind of gotten lost intentionally in that the kind of maze they created of obfuscating that request, you know, and overlooked it. But yeah, that was pretty impressive.
Yeah, I agree. I was shocked at some of the things that the LLMs have been able to identify. A related one that was also relatively shocking was base 64 encoded strings. You would think, like, how could it un base 64 encode something? But I think there's been enough like training data where it's looking at base 64 encoded strings that it actually has kind of maybe, I haven't verified this, so don't quote me on it, but I've seen instances where it looks at a base 64 string and it just says, oh yeah, it's running this shell command. And they actually tried using base 64 to hide it, but the LLM just looked at that and was like, oh yeah, I can decode that and figure out what it's doing.
Yeah, I mean, it is interesting that I think this is one of those things where AI can actually really be helpful, because it's doing a kind of a repetitive task that's kind of difficult, as you said. Like, I mean, the amount of lines of code and dependencies, especially, I don't know, I'm mostly a JavaScript developer, so like I feel like maybe it's a matter of perspective, but I feel like the JavaScript community is almost like it's just overloaded in dependencies at this point that I mean, yeah, you could go over it, but like, I mean, it could be somebody's full-time job just digging through all the dependencies all the time.
Yeah.
And there's always some new dependency added and et cetera. So it's a really tough task to ask somebody, but a machine can do it for you better.
Yep. And I mean, to be clear, I don't think today that the machine is necessarily doing as good a job as the human would. But if you're going to if the alternative is to do nothing, right, and to just install random code from random people on the internet, which is one way of describing open source, right, and using it without any type of vetting, I think having some kind of automation that can do a pretty good job is a really good starting point. And especially when there hasn't really been much in the way of scanning for these types of issues in the past. There's actually a lot of low-hanging fruit where the bad guys haven't had to try very hard to hide their tracks because just no one has really been looking. And so a lot of the attacks they're so easy to catch, in the sense of, like, if a human were to look at the code, like any of the code I showed you up there, right? If you were to open up one of your packages in, go to node modules in your editor and just open up one of those files and you saw that kind of code, you'd be like you'd be very mystified about why is this code like just a obfuscated block of all these weird functions. You could kind of tell right away as a human something is off. And so the LLM is able to do that pretty well, right? And help out.
Yeah, no, I mean, and there's a lot. I've even years ago, which you brought up in your last slide, like I think it was like 4 or 5 years ago. Not much has changed since then. I remember giving a talk regularly on like the license issues specifically, because most developers I talked to didn't seem to even know what licenses they were using. And this is not obviously a risk and a similar kind of risk, but it's a different kind of risk for like when you're working at a company and you put a license, in there that you aren't aware, that kind of puts you at risk of litigation instead. But even that was like getting folks to run like a simple license check prior to like installing something was difficult. So I
Yeah.
can imagine like getting them to go through the dependencies looking for stuff is also incredibly difficult.
Yeah. Yeah.
Um, but I do have like one question I have, which is kind of not getting at the actual risk in the sense of like how do we what can we do for maintainers that helps to mitigate some of like, because I agree, like part of our problem is that we keep putting more burden on these maintainers.
Mhm.
And I don't know that there's a lot of things where, you know I think the burden is increasing without necessarily anything to mitigate that increasing burden. We're relying on this stuff more, and yet we're not really providing for the people creating it in the way we should. What do you think are some things we could do to kind of, as a community, to help solve that?
It's a great question. I think, I mean, I have a lot of opinions on this topic because I've been a maintainer for a really long time, and I ended up deciding that doing open source full time wasn't something that I could do anymore. I'd love to live in a world where in the future, someone could decide to just do open source, and if you think about the value they're providing to the world by just working on open source and sharing this code with the whole, with all the companies that use it, with all the different folks that are using this code in different ways, the value they're providing to society is, I think, arguably more than you'd get as just a developer working on closed source code at a single company that helps one company, right? So, given that they're providing that much value to the world, it seems like there ought to be some way to compensate them, at the level of what you'd get at a job, right? If you're providing more, arguably more value than you can working on private code, why can't we compensate maintainers in a similar way? And there's a whole bunch of reasons for that are really hard to solve. That it's like, I mean, the main problem is if you give away everything for free and you put an MIT license on it, and then you turn around and say, please pay me, it's kind of like you kind of already given away the leverage in the relationship. So most companies just won't pay in that situation, right? Mm-hmm. Especially when you frame it as a donation, which is how most people do it. It's really hard for a company to, for a manager or for someone who, even if they care, they want to do the right thing, they can't really go and say, hey guys, we should donate. I want to donate the company's money to this random person. Like, it doesn't really, like, they can buy products, they can pay for support, they can pay for, but they need an invoice, and it needs to be like a formal process. You can't just be like, I'm going to go donate money from the company's bank account to this random open source person who I like, or who might even be my friend, something like that. You can't really do that. So the way it's been framed is, and there's obviously people doing good efforts here around this. I think Open Collective and Tidelift, there's some folks doing some experimentation and some innovation in the model to make it easier for companies to pay and to help. So I think paying is one big part of it. Then there's also like just maintainers themselves, I think, kind of create some of the burden. I mean, I remember when I was a maintainer, I was my own worst enemy in some ways. I treated my GitHub issues list as my to-do list, and I let effectively anyone in the world add items to my own personal to-do list. And that grew faster than I could fix the issues, and it created a lot of stress and a lot of just feeling of like, oh, I'm doing a bad job, even though I was like working more than 8 hours a day, like for free, giving away all my work. And I was like, I'm a bad maintainer. It's like, actually, that's not the right framing of things. And so there's I think a lot of maintainers I see that get burned out because they feel the burden of the people that are relying on their code, and they take it very personally. They really want to do the right thing. And so that can create a lot of stress. So there's a mindset shift, I think, that's helpful there, which is just like, you know, if you read the terms of the MIT license, it literally says this code is provided as is, right? As is, no guarantees. It's like if we really had that type of a philosophy around it, where it's like, there's no support contract on this. If you want support, that's a different thing. Maybe you should pay me for that. That can, I think, really help. The problem is, I think, is the mixing of the MIT license, kind of the standard open source licenses, and legally what they entitle the user to, which is not much. It's just, it's in terms of support and there's nothing that they're entitled to there. Whereas there's this sort of social expectation with GitHub that, and if you have an issue tracker, that you're going to be reading the issue tracker, that you're going to be engaging, that you're going to be addressing it. And so that creates this type of, this sort of almost, it's like a unwritten social obligation or social expectation that you're going to be there and you're going to support the users that show up. And then people get all confused about what is open source. Is open source the license? Is it this legal concept, or is open source the community? Is it the idea of having an open issue tracker? Because you have companies like Apple that just release open source code because they're legally required to, but they put it in a zip file on a random URL on their website that no one visits, and they call it open source. And technically, legally, it is open source, but there's no community. They don't take contributions. It's so then and so people think when they say open source, they really think of a maintainer who will reply to my issues and will read my PRs and will be engaged and will take contributions. And so, anyway, it's super complicated. I don't think we're going to solve it here, but I think, I don't know, government money toward it could help too. There's been talk of that, seeing it more as a critical infrastructure for the nation, I've seen the EU put money toward this, and there's interest now from the White House around open source security of critical projects. There's been money going toward that from the Linux Foundation, OpenSSF. There's these different organizations that are trying to funnel money to critical projects, identify critical projects, and then give them resources and stuff like that. So things are improving, but yeah, not enough, and not as far as it needs to go, I would say.
Yeah, it definitely is a complicated issue, and I've seen it. Even to the point where if you see a lot of companies even jumping out of open source because of a lot of the complications and things like that. So, which is a shame, right?
Right. You're talking about like the companies that don't want the cloud providers like Amazon.
Yeah, everybody's being able to have some other company take their service and just be like, oh, hey, we're gonna sell it now.
Right.
So I think there's so many different. We could have a whole other talk about issues around open source, not just security vulnerabilities, but yeah.
I think maintainers are just doing a ton of work, and it's such a thankless job, and it's one of these things where I don't know, we need maybe part of it is we just need a better way to hand off projects to new maintainers when people inevitably just move on. Like some people, they just have kids, they have a family, they don't want to do it anymore, whatever life changes happen for them, we don't really have a good way. Either you don't pass on maintainership and the package dies, or you do and then you take these security risks, as we've talked about in my talk, and it's not really a good situation.
Yeah, absolutely. Well, hopefully it gets better, as you said. Well, I really appreciate this talk for us. I learned a lot, actually. I knew about a lot of these, but the detail you went into was really fascinating. So I really appreciate the talk. Thank you for coming out, and thanks to everybody who showed up. I hope you enjoyed the session as much as I did. And I will be posting an edited version of this tomorrow. Until then, we will actually be back on September 8th. But I haven't posted that yet, so look for the upcoming event soon. So thank you all for joining. Thanks, Feross. Take care.
Thanks for the opportunity, Brian.